Hi everyone. In this video, we are going to talk about Python. I'm going to give you the very bare essentials of Python that would be needed to solve this homework and next week's homework. So Python is a programming language, just like MATLAB, and there are three ways of running Python that I will introduce to you today. One of which is through the command line. So Python, we're going to use syntaxes that are similar to that of MATLAB. X plus 3, if I type x plus 5, the result would just pop out right there. So that's one way of running Python. That's through the REPL. Another would be to run Python files immediately from a Python source code that you have written beforehand. So if I have hello world.py here, x equals 3, and then print x plus 5, I can run this Python file like so. Ta-da! Then I get my result in the console output. Okay, but if you are not familiar with the usage of terminals before and are more familiar with desktop apps, and then you don't have to worry, because the recommendation for this class is to use to install Python via the Anaconda distribution. By installing Anaconda, you would get not just Python, but also the text editor, and within the text editor you can run Python code. On top of that, you will also get this thing called the Jupyter Notebook, which I will demo soon. So you probably want to start off by Googling or YouTubing some installation instructions for Anaconda Python and Jupyter Notebook. And here's one YouTube video, and I'm sure there are a lot more. Or you can just Google it. It shouldn't be that hard. So I just want to show you that, okay, if you follow the setup, you will eventually land on this. This will set up a local server where the Jupyter Notebook will be hosted. If that doesn't make sense to you at all, just understand that you'll be able to access the notebook at this location in your web browser, and you'll be running Python code by writing code in your web browser. I'll give that a demo. I'm using Linux, but in Windows you might have a different way of spinning up your Jupyter Notebook server. So here is my current directory. There are many files, but I'm going to choose my notebook. I have intentionally trimmed this notebook from the bigger one from the course website here. So you can go through this detailed notebook if you want, but I have chosen the bare minimum that I think is enough to do the next two homework. Okay, so we're in the Jupyter Notebook. What can we do with this? You can write Python code, and for each, we call this a cell, you can run them by typing Shift and Enter. Ta-da! X equals 3, we print x plus 2, x times 2. This is Python syntax for exponentiation. X to the power of 2, that's where you get 9. And then finally, division. Very nice. And you can add more lines as you want. Print x times x, and then you get 9 at the end. Very handy. Note that in the notebook, if you were to quit from the notebook, oops, let's save these. If you were to quit from the notebook and open it again, your results are saved. That's why the notebook is a handy way of showing other people not just your code, but the results of executing your code. Okay, so that's basic math in Python. That looks similar to MATLAB. And if you notice, we don't have to do semicolons anywhere. That's another difference. Let's see. Next, arrays. I believe in MATLAB we call these lists. The syntax is still similar, but with two major differences. If this is my list, the two major differences are: one, when we index, we use square brackets, not instead of the round brackets. This will not work. You have to use square brackets. Second difference is we start from 0 and go to n-1. So if you want to get the first element, you would do list of index 0, not list 1. List 1 would give you the second element, and finally list 4 would give you the fifth element. Which means list of 5 will not work, because that will be equivalent to asking, give me the sixth element, which does not exist. Let's index out of range. And one handy thing is you can index backward too. Give me the first item from the back, second item from the back, and so on. And you might find this handy. If you just want to get a portion of the array, you can do array slicing. So list 1 colon 4 means give me index 1, 2, and 3. The last index 4 is excluded. That's another difference compared to MATLAB, I think. You can mutate your list. If I want to add an element to the end of my list, I can do list.append 10. Ta-da! Now my list has 10 at the end. If I repeat the cell, I would get another 10. Some useful functions. You can do sum of a list, and it would just sum the elements in the list. And Python has some handy libraries, one of which that you will use for the homework. Next week's homework is called NumPy. So the syntax is import and then the library name and you have as np here. Np is just a name that it's an abbreviation that you want to attach to the module name. So I could have called this my np, but if so, I would have to change all my code like so. But no, it is very common. Almost everyone abbreviates NumPy as np, and then you can access NumPy's useful methods like np.log, or NumPy's useful constants like np.e. Oh, and each cell, whenever you execute, would spout out only the last element in the cell. Okay, so let's examine what this code does. This method accepts an array, and this array has 1, 2, 3, 4 elements. The array looks like so: 1, e square, e to the 3. And then what do we do to the array? We say we call np.log. And nice thing about NumPy is a lot of the operations would automatically be applied to each element in the array. So this is equivalent to having log 1, log e, log of e square, and so on. And that's why we eventually end up with 0, 1, 2, 3, as we see here. Alright, so that's 1D matrix. What about 2D matrices? Again, we use NumPy for matrices. We could have used normal Python 2D lists, so we could have removed np.array like so, but then some functionalities will not we will lose some handy functionalities that only exist in NumPy. So even in the final homework, I believe we always enclose everything with an np.array. Okay, so what does this mean? This means it's a 2x3 array, 2 rows, 3 columns, 1, 2, 3, 4, 5, 6. If you want to select the second row, but all columns, syntax is the same as MATLAB, other than the square brackets and the 0 indexing. So remember, 1 is the second index. In this case, it's the second row, so you just get 4, 5, 6. If you want to select second column but all rows, you do this. You provide 1 in the column dimension. And if you just want to get the value of one cell, you do this. So this means give me the value of the second row and third column. 5. Wait, oops, sorry, second row, third column, 6. You get 6. Okay, some more handy attributes. So here is a syntax for printing. I can put my string, and then anything that I want to substitute later on, I can do this use this percent syntax. this %s will then be replaced by this value that I provided. But anyway, you don't need this for your assignment, but it's something that might come in handy. What you do need to know is you can get access to a matrix's row and column by using .shape. Shape is not a method. Shape is an attribute of a NumPy array. So if you want to get the number of rows of a matrix, you do math.shape, which returns a tuple. You can think of it as a list. Math.shape 0 gives you the number of rows. Math.shape 1 gives you the number of columns. So that it has 2 rows and 3 columns. Again, about the handiness of NumPy array, a lot of the mathematical operations will automatically be distributed along each element. So if we have 1, 2, 3, and you times 5, each one of them will be multiplied by 5. Very handy. Note that this broadcasting property will not work on non-NumPy lists. So we see that this guy is just a normal Python list without the np.array wrapper. What happens when you do times 5? It just repeats it times 5, which might be what you want to do. So but keep in mind that some operations would work differently depending on whether or not you're using NumPy array and Python list. Okay, back to our Python array. Vec plus 5, we would be adding 5 to each of the element 1, 2, 3. Now you get 6, 7, 8. And of course, you can do the same thing to vectors. Addition of vectors will just be done element-wise. Multiplication of 2 vectors would also be done element-wise. So 1 times 3, 2 times 4, 3 times 5, 3, 8, 15. Loops. The loops that you will end up using you will, for the most part, use just these 3 patterns. One is you might want to iterate over values in a list, right? So for I in values, print I, 1, 3, 5, 7. But what if you want to iterate through the numbers 0, 1, 2, 3, 4, 5 all the way to, say, 20? Well, Python has this handy method called range. You can think of range as creating a list that goes from 0 to whatever the number you provide minus 1. So range 20 is kind of like giving you a list that goes 1, 2, 3, 4, 5, but then you're to 19. But since you're too lazy to type this, then you just type range 20. If you already know Python, range doesn't actually return you a list, but you can think of it as a list for the purpose of the homework if you've never touched Python before. Okay, for I in range 20, you do print I. Ta-da, 0 to 19. Easy. Let's go through a more challenging example. Going through the integrator homework that we did weeks ago. We want to find the first index in the array such that the cumulative prefix sum would exceed the threshold. Here is how we would implement this. So if you want to iterate through an array, this is probably the for loop that you want to start with. What does this do? Let's see. Len r returns you the length of the array. So this is akin to writing for I in range 5, which means I will be replaced by 0, 1, 2, 3, and finally 4. Okay. So for I in range len r, I have a variable that starts from 0, and this plus equal sign is the same thing as cursum equals to cursum plus ri, but it's a handy shorthand. And finally, we keep looping, and if our cumulative sum is greater or equal than threshold, we print. Ta-da! Threshold of 5 was exceeded at index 2 with sum 6, because 1 plus 2 plus 3 is 6. We have exceeded 5 at index 2, which is the third element. Great. Other differences from MATLAB. If you notice, there are no and keywords after if and for. Also, you might notice that for and if we have colons at the end. And finally, instead of n, Python recognizes blocks of code through indentation. So after you have a for or if, you must indent. So if I were to do something like this, indentation error, expected an indented block. So take note of that. Indentation matters, and that's actually a good thing because it encourages better, more readable code for people who are learning Python early on. Let's see. Plots. You will be asked to do a scatter plot in next week's homework, not in this week. But here's how you can do it. Let's go through it really quickly. I want to plot 2 blue points and 2 red points. The red points' x's are 1 and 2, and the y's are 1 and 1. Same thing for the blues. You can create a figure of a certain size with this line, and then you can plot the red axis and red y's, and you choose color red, and this is how you specify the legend. As you can see, red label here, like so. Then you would make another scatter call to plot the blue dots. plt.legend will show this legend. Otherwise, if you hide this, then you will not see the legend. And finally, x label, y label, these are how you label your x and y axes. And title is the figure title. This is a minor thing. So if I hide this line, you'll see that there's this annoying thing at the very end. Why? Because for each Python cell, you would print out the evaluation of the very last line, and plt.title just happens to return this text object. So if you don't want anything to pollute your notebook, you just do this assignment thing that does not return anything. Okay, so that's scatter plot for next week, but I don't think you need it for this week. And next week, you would also need to play around to use random. So this is similar to MATLAB. Seed would cause the current random seed to be based on current time. That means it might as well be random. So if I run this many times, and ran returns you a random number between 0 and 1. So if I run this many times, you'll see that each call to random.ran would give a different value. But if I provide a seed, this causes numpy random to fix the seed, and so the random number generation process would always produce the same sequence of numbers. So I run this on many times, but the first number will always be the same. And what about the second number? It would also always be the same. So there is no true randomness in the world of computers. Random number generation is always a fixed pattern given a seed. The reason why you see the randomness in MATLAB and other programming languages is because the seed is based on something that is moving all the time, like the number of seconds in current time. Well, since 1970. Also, you can generate a vector of random numbers instead of just a scalar. So we have not been providing parameters to ran, but now we are too. So now you get a vector of random numbers. One more plot. We discussed scatter plot. We can also do line plots. Syntax is simple. X's and Y's. Ta-da. X1, Y5, X2, Y4, and so on. And if you want to attach more labels, you can look at the scatter plot code. Functions. You don't actually need this for the homework, but it might make your code be much nicer to read. So in Python, it's easy to create functions. You don't need to create new files every time. The first line always starts with a def, then function name, followed by the inputs to this function, or we call it parameters, then followed by a colon. Before you write your code, don't forget to indent, and then you do some computations here, and at the very end you return something. So in this case we would return the sum of the input a plus b. So let's do a demo. We define the function called add. We call the function add with 3 and 4, and we store the result at x, and then we print x. We get 7. Not surprising. And finally, this is what you will have to do for this week's homework. You will use Python to simulate an ordinary differential equation. So suppose you are given dv over dt is equal to negative v, and you're given the initial condition. You should know by now that this is just a decaying exponential. How do we simulate this differential equation? So far in MATLAB, we have just been using the Euler's method, right? But in most real-world applications, you will not be using the Euler's method, but another simulation method that would be more sophisticated. So here's how we can do it in Python. Let's start by we'll be using this library called SciPy integrate, which has this handy method called odint. Odint accepts 3 things. One is the dynamics. In our case, it's the dv over dt, the initial condition, which in this case is v naught equals 5, and t, which is a list of the time points you want to simulate the differential equations over. In this case, the t's is a list from 0 to 50, from 50 with increments of 0.01. So you call SIODint with dynamics v naught t. This would return you v's. The v's are then in MATLAB, you would be used to seeing vlist equals to zeros n. Well, v's are your vlist. That's the list of v values as you change time. Let's look at dynamics. The syntax of odint is such that the dynamics function that you provide will accept 2 parameters: the state variables, that is the stuff that's changing over time, and t. So state variables is a vector or a list containing all your t-dependent terms, but in this case we only have one, vt. How do we get vt? Well, the first element in Python is index 0, so you do state variable 0. That's your v value. This function expects you to return dv over dt. Well, since you already have your vt value and our dv dt is just negative v, then you just return negative v. So I could have written it this way, and this would be the same, but I just want to make it clear that what we are returning is the dv dt given v of t at current time. Wait. Sorry, so this should be t's. Yeah, now that you have all the t's and the v's, you can plot the line graph, and tada, we have a decaying exponential as expected.